Hey students, welcome back to chemistry. We're going to do section 3.4 that covers the concept of density today. So when you think about lily pads or things that can feel light for their size, there is a relationship between the mass of an object, meaning how much stuff is in it, how many molecules or atoms are in something. The ratio of the mass to its volume helps determine density, or it is the density. So a lily pad floats on the surface because it has a large volume for its mass. So it is lighter than water, so it floats on water. If it is denser than water, it'll sink. All right, so what determines the density of any substance? So let's talk about that. It is the mass divided by volume, or the ratio. One way to think of it is calling this a ratio of the mass divided by the volume. So I want you to imagine for a second, if I had a basketball and I had this basketball and I threw you the basketball and you caught it. You can imagine how much that basketball would feel like. What would it feel like, right? It's full of air. You've probably held a basketball or a ball similar size, maybe a kickball or a volleyball or a soccer ball or something like that. You can imagine what that would feel like. So you, for its size, for its volume, you kind of know that how much that air in the synthetic material or the leather that is around the ball, how much that's going to weigh, and you would prepare to catch it. Now imagine for a second that if I actually filled that ball with sand, so instead of air being in there, there'd be sand. You'd have much more mass. And I threw that ball at you and you caught it, it would feel heavier for the same size basketball, volleyball, or soccer ball. It would feel heavier because there's more mass in the same amount of volume. Likewise, if I have the same mass in a smaller volume, that it'll have a relationship with the density as well. So here's one way to think of that as well, for more of a chemistry example here. If I have 10 grams of a sample, have different volume because the densities vary. So for instance, lithium has a larger volume. Even though it's 10 grams, the density, mass divided by the volume of 19 centimeters cubed, or milliliters, remember that from our last one, centimeters cubed or cubic centimeters is the same as milliliters. The density is 0.53 grams mass per centimeter cubed, volume, grams per volume, mass per volume. Same thing with water, 10 grams of water. If I have 10 grams of water, the mass will be, the density will be 1.0 grams per centimeter cubed. And then lead. Lead is a very dense object. It has more mass in a smaller volume, so it is very dense compared to water and lithium. Okay, so these are some various densities of which you might experience, you might see around. So things like corn syrup has a density of 1, and water at 4 degrees Celsius, just below the boiling point, just above the freezing point, has a massive density of 1. So you can imagine that if I mix corn syrup and water together, the corn syrup would go below the water. Okay, for instance, solid water has less density. We'll learn about that later. Hint, hint, it's hydrogen bonds that makes it less dense. Gasoline or ethanol has a less dense, so it floats on water. So things that are made of oils, vegetable oils, gasoline, diesel fuel, ethanol, those types of oils are less dense than water. Likewise, things like gold and mercury and lead have these higher densities, 19, 13, and 11 respectively, and they'll sink in water. So these are all measured in grams mass per centimeter cubed volume. So the density is typically measured at a temperature, because remember the temperature is the measurement of the movement of the molecules. So the less movement, the more closely packed they can be. So this measurement is at 20 degrees Celsius, or about 72 degrees Fahrenheit. Okay, so here are some, the density of corn syrup is less than the density of corn oil is less than corn syrup. All right, so we're going to do, next time when we come together, we're going to do a lab that'll demonstrate some of this for you, okay? So how does temperature affect? We're going to talk about that, why these measurements here were made in 20 degrees Celsius, all right? So those are the standards. How would temperature affect the density, all right? So experiments That shows that volume. The hotter something is, think about this: as you heat something up, you're heating water on the stove, and that water, before it begins to boil, to put your delicious ramen in it, right? It begins to expand. That gas, so begins to expand as it turns into a vapor. That's really what boiling is. You're transitioning from one phase to the next, from the liquid to the gaseous phase, and so those molecules are getting farther apart. Farther apart they are, the more volume they're going to take up, which means you're dividing in your mass divided by volume equation of density, which means that you'll have a smaller density. Okay, so the warmer something is, typically the less dense it is. So the density of a substance decreases as the temperature increases. Okay, it's because the molecules are getting farther apart because there's more kinetic energy, so there's more movement, they're expanding. The same mass is taking up more space, so you have a less dense. Okay, so we'll switch over here to our little problem here. So we'll get this going here. Okay, so a copper penny has a mass of 3.1 grams and a volume of 0.35 centimeters cubed. So what we have to do is we have to write in what we got and what we need. What is the density of the copper? So this is what we got, WYG, oops, and this is a mass, and this is a WYG. Oops, I'll write it down here. A little bit of trouble with that thing there. And this is volume, all right? So remember, density is mass divided by volume. So 3.1 grams. Let me fix that. That's not good. There we go. Go back to that. 3.1 grams of copper, the chemical symbol is divided by 0.35 cubic centimeters of copper. Okay, so we would divide 3.1 by 0.35. And so that'll give us, using our significant figures of two significant figures, would be 8.9 grams per centimeter cubed. So this is only a correct answer if you have the right number with the right number of significant figures and the right units. Remember, density is mass over volume, mass over volume. All right, so that is that problem. Hopefully that is helpful for you. Rather simple problem to do. Okay, so we'll keep going, and let's do another one here. Okay, now we're going to go the other direction here. Okay, being familiar with this. All right, so a piece of copper has a volume of 0.3 centimeters cubed of copper, has a mass of 3 grams. That's about 3 times the volume of copper. 1 centimeter cube should have the mass of a 3 times larger, about 9 grams. This estimate agrees with the calculated results. It's very good. So we have that. That's good. All right, so let's try this one. A bar of silver. Let me clear all my results here. The bar of silver has, move this out of the way here, and we put it right down there. So a bar of silver has a mass of 68 grams and a volume of 6.48 cubic centimeters. So what you got, and I know this might seem a little elementary right now, but if you get in the practice of writing down what you got and what you need as these problems get more complicated, you'll be in practice and ready to organize yourself. Okay, so what we need is we need the density of silver. So I'll write there, that is what I need. Okay, so the density, I need to need density. So I remember density is mass divided by volume. And that's going to be 68.0 grams of silver. Chemical symbol of silver is AU, divided by 6.48 centimeters cubed. That's our volume of silver. AG, make better G there. Okay. And so we'll clear that as 68.0 divided by 6.48. Doing that on our calculator with significant figures, 3 significant figures. This 0 is significant because there's a decimal point there. So it's going to be 10. Ooh, let me fix that. 10.4. Oh, it's going to be 10.5 grams per centimeter cubed. Okay, so that is the density of silver, 10.5 centimeters cubed. Okay, so let me clear that, get rid of that. All right, so we're going to move on to another one here. All right, so we'll do one more here. That'll help you kind of process some things here. And then we'll be done our lecture lesson for today. All right, so we're going to use the first one here says use dimensional analysis to and the given densities to make the following conversions. So I have 14.8 grams of boron to centimeter cube of boron. The density of boron is 2.34 grams per centimeter cube. So let's write down what we got, or in this case, I'm going to underline. Let's get another color here. Let's get something in the yellow range. There we go. We'll get something in the yellow. I don't like that color either. How about? There we go. We'll get a little of that in our life. Okay, there we go. All right, so we have grams of boron. That is a mass. So in my what you got section here, I have my mass equals 14.8 grams of B. The elemental symbol for boron is B. And I also have the density, which is 2.34 grams per centimeter cubed. And it wants me to convert or tell me how much that is in centimeters cubed, which is a volume. So my what you need section here is going to be volume. All right, so let's write out my equation equals mass over volume. And if I rearrange my equation, volume is going to be density times mass. These two just switch algebraically. I'll let you figure that one on your own. You've had enough math to figure that one out, right? All right, so I'm going to go ahead. I'm going to need to make some room here. So I'm going to clear all this. So just rewrite this. Volume is density times my mass. So volume equals 2.34 grams per centimeter cubed. Okay. Times my 14.8 grams. And just remember, this is our, oops, I did that wrong. I say I was already doing a dimensional analysis in my head. And this is why you do dimensional analysis in your head. I did my algebra wrong. So I'm going to do it here just as a penance to you guys. If density equals mass over volume, I'm going to have to multiply each side times volume. Okay. And then this is going to be mass divided by density. So I was wrong. So I'm going to clear all that again. So I made a mistake on the screen. Okay. So my density is going to be mass divided by density. There we go. I think that's going to work out for us now. So 14.8 grams divided by 2.34 grams per centimeter cubed. Okay. And then so let's see here, 14.8 divided by 2.34. 2.34. and it gives me 6. Keep our significant figures to 3. So that's a point there, 3, 2. 6.32 centimeter cube. Okay, now I want to show you how these units, this is how I knew I was going the wrong path and I corrected myself midway. So here it is right here. Here's grams over grams per centimeter cube, right? So my answer needs to be in centimeters cubed because that's what it's asking for here, right? So remember your math from the 7th grade. It's when you divide fractions, you keep, change the divided sign, and keep, change, flip. Okay, so I flip this one upside down. I flip that one, see how my grams cancel out. I'm left with that. So that's how I know I was going the wrong way. So that's where dimensional analysis actually saved me, that I shouldn't have done my algebra rearranging in my head. I should have gone ahead and written it out. So that's a good lesson. Learn from your teacher. I get it wrong a lot. So check yourself before you wreck yourself. So that is it for our lesson for today. I hope you find this helpful, and I'll see you soon. Bye-bye.